Hey, what's going on, ladies and gentlemen? Welcome back to Learning Roblox Studio. In today's episode, we are going to be going over the Controlling the Player's Camera course. As always, if you guys do enjoy the video, make sure you smash the like button, also hit the subscribe button, and turn those post notifications on if you guys do enjoy and want to see more Roblox development content when I do upload it. As always, I do have Patreon. If you guys would like to support me, there's a link down below in the description. You guys go check the Patreon out and gain access to a lot of the scripts that I make my other videos. Finally, I do have a link down below in the description to the article that's on screen right now. If you guys would like to follow along or read it at all, there's a link down below. You guys can go ahead and check that out. With that being said, let's get into it. Getting started. The player's view of the world is represented by a camera object. Camera behavior can be changed to suit your game in a variety of ways. For example, the camera can react to events in the world, such as shaking when a monster walks by, or placed to the side of a player, such as in old school side scrollers. Creating a first-person camera. A first-person camera is a view where the camera stays locked with the player's head, which is more accurate to real life. It's common in shooters and story games where the goal is to make the player feel immersed in the world. We can then see the two images. On the left is the first-person camera, and on the right is the classic Roblox camera, which is kind of like a third person. I don't know the exact term for it, but it's definitely zoomed out. So now let's make sure that we head over to Studio. It doesn't really matter what project you load up. I just load up the project that we've been working on this entire series. So in Studio, the starter player object contains a number of properties that will affect the player's camera. The camera mode property determines how the camera will behave. So if we click on the starter player, which kind of looks like a folder, but we can then see a bunch of different properties here, and we can actually see a category called camera. So we want to change the camera mode to lock first person. This will ensure the player's camera doesn't move away from their head. So we can see the camera mode right here, and we can set that directly to lock first person. Now let's go ahead and test this out and see what it looks like. And we can see that our camera is locked to first person, and when we try to scroll out, it does not actually scroll out. Also, since our cursor is stuck in the screen, we can either press escape, which actually doesn't work for me at all, or hit shift and F5, and that's the hotkey for actually stopping the game that's running. Additionally, there is F5, which will start the game, and then of course the opposite would be shift F5 to stop it. Don't worry, you won't be locked in the game as long as you know that hotkey. Creating a side-scrolling camera. A side-scrolling view keeps the camera at a fixed position relative to the side of the character, giving the world a two-dimensional feel. And the image is obviously an example of what a side-scroller looks like. So, scripting the camera. Expand the starter player, and in the starter player scripts, add a local script. So, let's go here, add a local script, and we're going to name that Camera Manager. At the top of the script, get the player service, and then in a new variable, get the local players. So, local players equals game get service layers, and then we are going to get the local player. We're going to say local player equals players dot local player. Then we want to create a function called update camera. So local function update camera, and this will actually hold the logic needed to get and set the position for the camera. Inside of the function, get the player's character model and check if it exists by using an if statement. So local character equals player dot character, and then if character, then pointing the camera. All character models contain a part named humanoid root part, which can be used to get the character's position in the world. This will be the position the camera points at. Use find first child to get the humanoid root part and check if it exists using an if statement. So inside of the if statement that we already have, we're going to say local root equals, and then inside of the character, we're going to use the find first child function to see if we can find the humanoid root part, and then if that part does exist, we're going to do something. The position of the humanoid root part is actually 2 studs below the player's head. To fix this, add a new vector 3 with the height of 2 studs to the root's position. So create a new variable called root position, and we're going to set that to the value of root dot position plus a brand new vector 3, so vector 3 dot new. And if you guys don't know what a vector 3 is, we can see up here returns a vector 3 with the given x, y, and z. And when it comes to position, the Y is sort of the up and down position. So we're only going to add something to the Y, and we kind of want to just add 2, for instance. So we should write 2 here, and then we also want to put 0 as well, because we don't want to adjust the Z or the X axis. We only want to adjust the Y. So then we're going to add these 2 together, and that's actually going to increase the Y position of it by just 2, while not increasing or decreasing any of the other things. Additionally, they don't really explain it that well in the documentation, but they want us to make a new constant up here called height offset, and they want us to set that to the value of 2, and they want us to put the variable into here. And I can see why they want us to do this, because it would be easier to tweak it later. Although I don't usually do this in my own projects, but I guess I could see the benefits of it. Constants will never be modified within the code, but let's say you come back to this project at a later time, and maybe for some reason you want to change this from 2 to 5 because you want the camera to be a little bit higher up. Then you'll be able to look at the top of your file and easily see what variable you need to modify, rather than needing to remember this whole code and like what this specific number is there for. That's just an example of why they're suggesting you use constants. I kind of like the idea, honestly, although I just don't use it myself too often. Maybe I should. Continuing with the lesson, setting the camera position. The camera will also need a position. To give the player's view a 2D side-scrolling look, the camera will need to look directly at the side of the character. Place the camera to the side of the player by adding depth to just the z-axis of the camera's position using a vector 3. So we're going to create a new variable and we're going to say camera position, and we're going to set that to a vector 3.new. We're going to get the root position.x, the root position.y, and the root position.z, and then we actually want to come up here and we want to create a new constant called camera underscore depth, and we're going to set that to the value of 24. Then instead of getting the root position z, we're actually going to use that in here. Update current camera. Now that the variables for the camera's position and the camera's target are ready, it's time to update the camera's position. The player's camera can be accessed through the current camera property of the workspace. The camera has a C-frame property to determine its position. You can use cframe.lookAt to update the camera. It takes two positions and creates a C-frame located at the first position pointed towards the second. Use cframe.lookAt to create the C-frame that is positioned at the camera position and point towards the root position. So underneath our player variable, we're going to create a new variable called camera, and we're going to set that to workspace.currentCamera. Then inside of our function below our variables, we're going to say camera.cframe, and we're going to set that to cframe.lookAt, and we're going to pass through the camera position and the root position. Sync the camera. The last step is to run this function repeatedly to keep the camera in sync with the player. The image the player sees is constantly refreshing. The split second it takes to do all the calculations necessary is called the render step. Run service bind to render step function makes it simple to execute a function on every frame by accepting these three parameters. The name is the binding, which should be unique so it won't clash with other functions of the same name. Priority. The higher the number, the higher the priority. This function should run after Roblox default camera update, so the priority is set to one level higher than the internal camera's render priority. Finally, function. The function can be bound to the render step. So now we want to call the run service below our players. Local run service equals game get service run service. And now at the very bottom of our script, we're going to say run service, then call the function bind to render step, and we're going to pass through a name, which is side scrolling camera. Then we're going to set the property using an enum. So we're going to say enum.renderPriority.camera.value plus 1. So we're setting the priority by actually getting the render priority of the already existing camera. And then we're just adding 1 to it. So this will actually have a higher priority than the default camera. And then finally, the last thing that we need to pass through here is the actual function. And we are going to pass through update camera. Let's go ahead and hop into our game and test this out. So we can see that it is working. I mean, we are very, very far zoomed out, but it is definitely working. You need to use W and A to actually like move around, or at least move like in a direction that you can see with the camera. If you hold S or W to go forward or backwards, the camera doesn't really move that much, but it definitely is working. Additionally, I'm pretty sure they forgot to mention, but make sure you go to your starter player and then you modify the camera mode back to classic from lock first person if it's not working for you. Now let's say that we don't want the camera to be so zoomed out. Currently the camera depth is at 24, which actually makes the camera really far away from the player. You would think decreasing this number would actually make it closer to the player, but it's actually kind of the opposite. If we adjust the camera depth from 24 to 240 and start our game, we can see a pretty big difference. So now we can actually see the camera zoomed in a lot, but still isn't really what I would like. Let's try 340. 340 is actually really nice. I didn't think that would be the number, but yeah, 340 is pretty good. It makes it a lot closer, creating an isometric camera. The basic structure of getting a player's position and updating the camera's position every frame can be adapted to many other camera styles. An isometric camera is a 3D view pointing slightly down at a fixed angle towards the player. Modify position and view. Using the code from the previous example, modify the camera position to add the same amount to all 3 dimensions. So go back inside of our update camera, we can see the camera position, and this time, instead of using the root position, we're actually just going to use the camera depth for all 3 of these arguments. We're still going to use the root position for the C-frame look at, because this is actually what points it towards the player, but the position of the camera is what we're going to actually be modifying. And then additionally, we want to change the side-scrolling camera because that's no longer what it is. And when this isn't mandatory, like you don't need to name it this, but this is kind of good for organization. And we want to rename it to Isometric Camera. Changing the camera's field of view property will simulate zooming in and out, which can give the view a flatter look. Try setting it to a value of 20 to zoom in and increasing the camera's distance from the player to compensate. So let's go back up to the camera depth and let's change it to 64. And let's also modify the default camera's field of view property, and we're going to set that to 20. Now this might look a little odd to you because we're actually changing the property outside of a function. Don't worry, that's completely fine. When a script runs, it's going to go from top to bottom. We get the current camera from the workspace right here and set that to camera, and then we just modify the property, and then we continue to go down the script. I probably don't need to explain that to you at this point, but still I felt it might be worth it. Now let's go ahead and start our game up and see how it looks. So now we see it definitely does look a lot different. It is pretty odd, I'm not gonna lie. I've not really sure or seen games that kind of use this camera positioning, but it is definitely working. By changing the way the camera behaves, you can achieve a whole new look for your game. See if you can change the camera position to achieve a top-down game with the same script, and try tweaking the settings to get a result that you like. So we're gonna try to do that. On screen right now is an example of what a top-down game actually looks like if you're not too familiar with them, and that's the camera angle that we're going to try to get to. Okay, so I'm not too familiar with top-down games myself. I think that I've kind of created it. I think. I don't know. You could be the judge of that depending if you play top-down games or not. What I did is I removed the FOV modification that we made. I set the camera depth to 350 and kind of went back to the original way that we were doing this. So the camera position is a vector 3 of the root position X, the root position Y, and then I actually increased the root position a little bit because we want it to be above the player, so we're increasing the Y. And then I just set it to the camera depth so that the camera is a little bit further from the player as well. We kind of want the camera to be at an angle where it's above and a little bit further from the player too, while of course the player is still directly in the middle of the screen. And that's exactly what it created. I don't know if that's exactly how top-down games work, but I tried my shot at it. Anyways, ladies and gentlemen, hopefully this video did help you guys out. If it did, as always, make sure you smash the like button and hit the subscribe button and turn those post notifications on if you want to get notified when I upload more Roblox development content. As always, I do have Patreon if you guys would like to support me or gain access to a lot of the scripts that I make my other videos. There's a link down below in the description. You guys can go check it out. With that being said, I hope that you guys have a great day, and I'll see you guys in the next episode. Peace.